how do we take the derivative of this implicit function? All you have to do is that, okay, let's first write it out. We have x squared plus 2xy plus y squared equals to 0. Oh, equals to 5. Okay. Now pay attention, please. We are still going to go the same way. Okay. If you want to differentiate x squared, you are going to have 2x, right? Now, because we are differentiating with respect to y, we are differentiating y with respect to x. Anytime we differentiate y in this equation, we're going to add dy dx, okay? So in that case, this will give me 2x plus, now pay attention, we have 2xy. Let us bring these two out and open the bracket. Now we are going to take the derivative of xy separately, and when we are done, I'm going to put it inside the bracket. Do you understand? Listen to the explanation again. The goal is to find the derivative of y with respect to x. Now we want to differentiate 2xy, but 2 is affecting both x and y. So here, what I did was that I just bring out these two. So I want to take the derivative of x and y separately. When I'm done, I'm going to put inside the bracket. Are you paying attention? So let us differentiate xy. Now we have xy. What is the sign between x and y? The sign between x and y is a product sign. And there is a rule in differential calculus that we can use to differentiate a function that looks like this. This function has two parts, and these two parts are multiplying each other. We can use the product rule to differentiate this function. According to the product rule, we have to keep the first part constant, differentiate the second part. This is the first part, x is the first part, u, and v, which is y, is the second part. Okay, I just represent it as u and v. See, according to product rule, if you have to differentiate a function that is multiplying each other, you are going to keep the first part constant, differentiate the second part, add it to differentiate the first part, keep the second part constant. Okay, now with respect to what we have here, you can follow the same approach to differentiate x and y. Now x is u. The first step is to keep u constant. So I keep s constant, I'm going to differentiate y. And I told you, when you are differentiating y in an implicit function, when you have to differentiate something with respect to another thing, that thing that you are differentiating, you have to add the derivative of that thing. Because I'm differentiating with respect to y now, I'm differentiating y with respect to x. Hence, anytime I differentiate y, I'm going to add dy dx. Do you understand? So I want to find the derivative of y. The derivative of y is 1. So I'm going to have x multiplied by 1 dy dx. Plus, now I'm going to differentiate u. U is x, so I'm going to differentiate x. If you differentiate x, you're going to have 1 multiplied by v. V is y, so I'm going to have multiplied by y. So here I'm going to have x. 1 times dy dx, that is dy dx. So I'm going to have x dy over dx is equals to y. x dy dx plus y. Okay, so let us put it inside the bracket again. X dy over dx plus y. That is the derivative of xy. Okay, so let us proceed. Now we have y squared plus, now if you differentiate y squared, you're going to have 2y. But because this is an implicit function and we are differentiating with respect to, we are differentiating y with respect to x, I'm going to add dy dx. So I'm going to have 2y dy dx, 2y dy dx equals to 0. Because if you differentiate a constant, you're going to have 0. Okay, so I'm very sure you understood what I did here. If you didn't understand, kindly reverse the video and listen to the explanation again. Okay, now we have 2x plus 2 times x dy dx, that is 2x dy over dx plus 2y plus 2y dy over dx equals to 0. Okay, what I did is that, this is what I did. 2 multiplied by x dy dx, that is 2x dy dx. 2 times y, 2y plus 2y dy dx. Okay, now let us proceed. The next step is that you have to collect like terms. Those terms that have dy dx, you leave it at the left hand side of the equation, and those terms that do not have dy dx attached to it, you take it to the right hand side of the equation. Okay, so here I'm going to have 2x dy dx, 2x dy dx plus 2y dy dx is equals to, now if this 2x crosses the equals to sign, I'm going to have negative 2x. Okay, and if this positive 2y crosses the equals to sign, I'm going to have negative 2y. So I'm going to have negative 2y all over, oh sorry, I'm very sure you understood how I got here. What I did was that I collect like terms. This doesn't have dy dx. Likewise, 2y doesn't have dy dx. So I take it to the right hand side of the equation, and because they are both positive, both of them, they are going to have a negative sign. Okay, so factorize, I'm going to have 2x plus 2y is equals to negative 2x, negative 2y. Now, the next step is that I'm going to divide both sides by what? By 2x plus 2y, because what I'm looking for is dy dx. Dy dx is what I'm asked to find. So, in an attempt to help me to solve for dy dx, I have to divide both sides by 2x plus 2y, because both of them, this is attached to dy dx. So, if I divide both sides by 2x plus 2y, dy dx is going to stand alone. Okay, so I'm going to have this over 2x plus 2y and this over 2x plus 2y. Now, dy over dx is equals to negative 2x, negative 2y, all over 2x plus 2y. I'm very sure you understood how I got that. Now, you can factorize 2. Both numerator and denominator. Okay, so I'm going to have dy all over dx is equals to, now, this will be negative 2 into bracket x plus y all over 2 into bracket x plus y. Oh, sorry, x plus y. Do you know what I did? Negative 2 is common to both x and y at the numerator. So what I did was that I factorized it out. And I opened the parenthesis, x plus y. If you take the product of negative 2 and x, you're going to have negative 2x. Take the product of negative 2 and positive y, you're going to have negative 2y. And at the numerator as well. If you take the I factorize 2 because 2 is common to both x and y. And if you take the product of 2 and x, you're going to have 2x. And if you take the product of 2 and y, you're going to have 2y. Okay, so hence, this can cancel this. Likewise, negative 2 divided by 2 is what? Negative 1. So the y, derivative of y with respect to x is negative 1. That is the final answer. Okay, now let us proceed to the third question. You can see that it's simple. It just required thorough attention when you are differentiating